Welcome back to my lectures on blockchain technology. And in this video, I'm going to talk about cryptography hash function, one of the key technology used to secure the blockchain network. Okay, let's start. Before explain more about cryptography hash function, let's see why we need cryptography hash function. Okay, let's look at this figure. You see, this show a blockchain network. We have a lot of nodes in here, and in each node, they store the blockchain ledger. Let's say each block in the blockchain ledger will have maximum up to 1 megabytes data size, and there is one block will be created every 10 minutes in average. Let's say the blockchain system already operates for 10 years. It means that there are 262,800 blocks has been created, or the total size of the blockchain ledger would be 256 gigabyte data. This is a huge ledger, and on the nodes here, they must store this huge amount of huge ledger, 256 gigabyte data. So how it can detect whether is there any modification, any other unexpected change of the data in blockchain or not yet. So that's a big problem. How to detect the unexpected change in blockchain ledger quickly. Of course, it cannot compare one by one the data because the data is very huge. A lot of data cannot compare such so like that. So is there any method to detect the modification quickly? That's where we should use cryptography. So what it is? So in this figure, you see this is a hash function, crypto hash function. So it receives an input data and it will calculate the hash of the data. And the calculation is just one way calculation. From the hash of data cannot get back the original data. Okay. So currently there are several algorithms for the hash functions. For example, MD5, SHA1, SHA2, SHA3, and so on. So for example, in SHA3, SHA2 families, there are many algorithms such as SHA256, SHA510, and so on. And these functions are commonly used nowadays. So for example, if we input an input message, hello world, and if we calculate the hash value, so each hash function will generate a different hash value. MD5 it generates the hash value like this, SHA1 is like this, SHA256 is like this, and this is the hash value of the SHA to 5000 intel, SHA 500 intels. Okay. What are the patterns of the hash function? So we have independent hashing, repeated, combined, sequential, or hierarchy hashing. For example, this is the independent hash. So we have the hello world message. We can calculate the hash of each word independently. Or this is the repeated hash. So we can firstly compute the hash of the hello world and then compute the hash of the hello world. Repeat the hash. Or combine, we combine the hello and word, independent words into one word, and then calculate the hash of the combined word. Or the sequential hash, we can compute the hash of the hello and then combine this hash with the words, and then calculate the hash of the final. Or hierarchy, we calculate the hash of the hello and words independently, and then we combine these two hashes and calculate the hash for this combined hash. Okay. Properties of the hash function. Properties of the hash function is very important because It shows that whether the hash function is enough secure for using or not. So this is the important properties for a hash function. Firstly, it transforms any kind of data into a fixed length output. For example, if we say about SHA256, so regardless of the size of the input data, it always generates 256-bit hash output. Always 256 bits. Okay. And the next property is calculation quickly. It means that the hash function should be able to calculate the hash of the data very quickly. Therefore, when construct a hash function, we should use the simple operation like logic operators such as and also not. Sometimes we use the adder, but the complicated one like multiplier or divider should not be used. Okay. The next property is deterministic. It means that for a data, there is only one hash value will be generated. There's no case that two hash for one input data. Okay. The next is very important is the pseudo random. Pseudo random. It means that the output hash value is somehow random. For two input data that is similarly, for example, they even different only 1 or 2 bits, but their output hash value should be completely different because the outputs are random. It seems that there is no relationship between the output hash and the input data. So that's the property of the hash function that we should achieve. The next is one-way usage. It means that the hash function can calculate the hash of the input data, but from the hash output, we cannot estimate any information of the original data of the input data. Cannot, because it's one-way usage only. The next is collision resistant. It means that it is very hard to find two input data having the same hash value to avoid the collision may cause during the operation. The question here is how to detect the change of blockchain ledger quickly by using the hash function. Okay, so remember that blockchain is a chain of blocks connected via the hash values. Here we have block 1 that store the dataset 1. To create a new block, we must firstly compute the hash of the data in the block 1, and then this hash will combine with the dataset 2 stored in the block 2 to form a new information. And then to create new blocks, we need to compute the hash R2 of the dataset 2 and the R1 here. And similarly, from here, R2 combined with the dataset 3 to make a new blocks, and then we compute the next hash R3 for the new blocks, and doing so on. By doing like this, you see that a little change of data can cause the change of the final hash value R3 in here. For example, let's say if there's some modification in the dataset 1, so it will result to the change of the R1. And R1 change is mean that R2 will change. R2 change is mean that R3 will be changed, right? So finally, we only check the final hash R3. If the R3 is changed, it means that there is already some modification inside the blockchain ledger. We don't know where it has been modified. We don't care and we don't know. But we just know that we can sure that the blockchain ledger has been modified if the R3 here is changed, right? So finally, we can check R3 only. We will check R3 only here. So Merkle T. Let's see the situation like that. Let's see the situation like this. If there are many messages will be stored in one block, how to compute the hash value of that block? Let's say we have 4 messages. Message 1, 2, 3, and 4. So the calculation of the hash will follow the Merkle tree. It's calculated like this. Firstly, the hash of these messages will be calculated independently. R1, R2, R3, and R4. Okay. And then it's combine the hash of 2 messages into one new message and compute the hash of the new combined hash here. For example, here we calculate the hash R12 of the combined hash R1 and R2, or R34 for the combined hash R3 and R4. And finally, we combine these two hashes R12 and R34 into a new message and calculate the final hash. And finally, the final hash is called the Merkle T root hash, will be stored in the block header. By doing like this, if there are several thousands of messages inside one block, so the Merkle T hash function, the calculation will become complicated and time consuming. What are the steps to create a new block? Basically, it follows 3 steps. So in this figure, it shows now we have block 1. And now we want to create a new block, block 2. And block 2 should store the message 3 and 4. So in first step, it generates the Merkle T hash for message 3 and 4 to finally get the Merkle T hash root R34. And the second step is form the block header by combine the Merkle T hash R34 with the previous hash B1 and some other information. I will show you later. But it generates the header for block 2. And in step 3, it finds the new block hash for this header B2. Okay, there are 3 steps like that. Here is the structure of a blockchain ledger in more detail. Say we have a blockchain ledger that has several blocks like this. Block 51, block 52, 53, 54, block N, and so on. And in each block, there are transaction data. Sometimes we can also call it as the message data. Transaction A, B, C, D. And from this data, the Merkle tree root will calculate the Merkle root hash function. And the Merkle root hash will combine with the header information to form a new header. From this header, calculate the block hash. So in each block, you see that there's the transaction data that we want to store in this block, and the hash of the previous block and the hash of current blocks. There are 2 hash values will be stored in each block. Okay, so that is all for our lecture today. If you have questions or comments, please send me emails or comment in the below of this video. Thank you so much for your attention.